After understanding or realizing why a finite element method is important, who can learn finite element method, how can it be learned and when can someone learn finite element method, let us see what is finite element method in the next slides. As this course will be completely answering what is finite element method, what are the steps involved in finite element method, what are the different elements, the step-by-step procedure, its advantages, disadvantages, what are its limitations and what are its applications, and how a finite element method will be used to analyze the structure. Now let us close our eyes and imagine a building. Does the building is simply designed and constructed? Definitely no, right? So it has to be planned, it has to be designed, analyzed and tested for failures and worst scenarios in case of earthquake or wind. Then it will be designed as a structure physically by using materials. So I'm talking about a structure which is being constructed and built in terms of a building, because this finite element method is mostly focused towards civil engineering students. So now let me introduce the finite element method to you. So before introducing the finite element method, let us imagine a building. So the building is first visualized by the designer or a structural engineer or a civil engineer. Then a proper plan will be created. Then after creating a plan, it will be designed with all the structural components. Then after designing the structural component, it will be developed as a whole structure and that will be tested. Earlier, this structure will be developed by imagining, creating, designing, and as material will be involved. A small prototype will be made and it will be tested if the structure is critical. Imagine a 20-story building. So earlier, manpower, material and cost is involved. But nowadays, without wasting material, manpower and time, using a software tool, the structure can be designed, developed, analyzed and tested even before construction. So as the structure is intended to service during its lifetime, it is also focused to have a good aesthetics in order to have a long durable structure. So the reason why I discuss about building a structure is looks so simple, but there are so many other steps that is involved to develop a structure which is safe when it is exhibiting or experiencing towards a seismic force in case of an earthquake, a flood in case of rain, or heavy wind in case of a cyclone. So how can we test a building against seismic force, wind force in case of a cyclone, or flood in terms of heavy rain? So because of the available technology and the software tools, any structure can be analyzed by using finite element method to calculate its deformation. The reason why I say deformation is when a building is subjected to an earthquake or a wind load or a flood, it deforms because most of the engineering structures will fall. Finite element method is one of the tool that is available right now with the engineers to evaluate the structure as a whole or as an element in case of a structural element. So now without wasting the time, let us go to the introduction to finite element method. So as I told you, any structure which is developed by plan, by using a software, have to be constructed and it has to be analyzed. So earlier, as I told you, we used material to make an actual prototype with a small scale and it is tested. But now with the use of software tools and the technology, an engineering analysis can be performed even before constructing or designing the structure. So there are three types of engineering analysis, or three methods of engineering analysis is involved. The first one is the experimental method, analytical method. The last one or the third one is numerical method or approximate method. So as the name goes, experimental method, it can be done through experimental models or prototype. So since it involves an experimental method or a prototype, it needs manpower and materials. So since manpower and material is involved, definitely it will have a time consuming process and cost is involved. Nowadays we are not actually going for an experimental method unless otherwise the project is so critical and important. So in case of a satellite or a rocket launching by ISRO or NASA, they will definitely go for experimental model or a prototype scaled down to the model. But now in case of a prefabricated or a precast structural members, the members will be tested in a lab environment and then the construction will be implemented. But we cannot employ the experimental method of engineering analysis for all the type of structure. So that will ultimately lead to increase in the cost, and also it is time consuming. So the second method is the analytical method. So the whole problem will be expressed by a mathematical differential equation. As it is an analytical method that will be involved either using mathematical equations, it gives you a quick and a closed form solutions. It is used for the simple geometries and idealized support condition and loading condition in case of a civil engineering structure. It can be used only for a certain situation, but not for the structure which is assumed to be critical. So this analytical method will be used for a simple phenomenon, for a simple geometrics, and for the ideal support condition. For example, if I can use an analytical method to analyze a simply supported beam that carries an UDL or a uniformly varying load or a uniformly distributed load, to calculate its deflection and the stresses in each individual beam element at different cross-sectional areas. But I cannot use an analytical method for a greater geometrics, or the condition is not idealized. So these are the few drawbacks in using analytical methods. The last one is the numerical methods or approximate method. So as I told you, when the problem involves a complex materials or a complex boundary conditions, numerical methods or approximate methods are preferred. It gives you or gives us the approximate but acceptable solution. So imagining a rocket launching site. So the rocket launching pad or the structure that is constructed using concrete. So during the propulsion, the concrete will undergo enormous amount of heat. So the concrete has to withstand that amount of energy of heat. So we cannot construct a concrete structure in the rocket launching platform and to test it during the propulsion. So in such cases, we can go for a numerical method and approximate method to see the temperature stresses in the concrete